Alright. So we're doing 1 and 2, I'm try to do 1. We have this equation, this function, we're trying to evaluate it at a plus 0.1 and estimate f of a plus 0.1. Plug a with the function to get a y value, and we have a point, take the derivative of the function, and plug in the x value, and we have a slope, find the linearization, and use it to estimate the value of the function. Yes?
The book wanted you to find the linearization and then compare it to the F.
Oh, so plug 2.1 into f, what did you get?
8.061, and then for the L, or the one that you just made, I got 8.1.
8.1?
Yeah.
What the heck?
And it's
Why?
well, I kind of like simplified this. It's kind of minus 13, and you always plugged in 2.1, so it'd be 10 times 2.1 minus 13.
I did the same
When
thing.
you was one.
What?
I did the same thing as the guy.
Oh. Yeah, don't distribute this because it's easy to multiply 0.1 times 10. And if you distribute, then you have 10x minus 20. 10x is 21 minus 20 is 1. Plus 7 is still 8. I think you should have gotten 8 still. But don't distribute, like there's, yeah. 0.1 times 10 is easier than distributing some more stuff. Okay, so let's do 2. We have -4 from 2. Half of 2, it's -2, isn't it? Is the square root of 16 minus 9. So that, it's not nice. Let's just look and see. This is weird, huh? So we have the point -4 is 37.
It's plus.
Yes.
So it's 5.
Oh, thank you. Dang, that's terrible. No. Okay, so let's find f prime of x. It is 1/2 square root of x squared plus 9. Come on. That's right, right? And then f prime is -4. -4/5. linearization. Um, Is that 3.9? Negative 4 plus 0.1? Half. 3.9. Negative 3.9. One tenth times 8/10. 800. .92. And what is f of negative 3.9?
4.9204.
Ooh, it's close. Everybody good? This. Take the derivative. These are all multipliers. So if you have a sum here, you need to put parentheses around it. Oh, we don't. So dy evaluated when x is high and dx is negative 0.1. Sine of 0. 0. So e to the 0 is 1. Cosine of pi. Oh, sine of pi. It's still 0. Right, we're plugging in pi. Sine of pi is 0. E to the 0 is 1. Cosine of 0. Cosine of pi, I mean? Negative 1. Times 1 times negative 1 times negative 1. Right? Problem 23. 22. What?
It was in that same section.
Go up.
Oh. Implicit differentiation. Plug 2 in to find y. Do we find y? Oh yeah, because divided with x will have x's and y's. 2 like line. First times the derivative of the second plus the second times the derivative of the first. So we still need to know what y is. Looks like y is 1. What is that? 5 100ths? 120th? We good?
Wait, this was, I got negative 1, 4. I don't know.
How?
I don't know. I don't know. I got, well, when I found dy over dx, I got, 3x minus y over 1 minus x. I don't know why.
I like mine. Carly, I love you. I love you.
What?
Because you did the problem and you think you're right. And you took a picture of mine to find where I made a
Well, I don't know
mistake.
what I did wrong.
You are amazing.
I don't know
Is it
what I did.
okay if I appreciate this moment?
Yeah.
I do. And I'm still giving myself like a 70% chance of being correct. Any questions? So dy dx is secant squared x, right? So dy is secant squared x dx. Secant of pi. This is the point -1 is 0. Secant is the reciprocal of cosine. It's still -1. Is there a choice? Feeling good about that one? Any questions? Alright, heavy weights. So we're just taking the derivative. It's kind of like implicit differentiation. But we're taking the derivative in terms of time, not in terms of x. So it's not dy dx, it's dy dt. In this case, it's d dt. So when you take the derivative in terms of time, you take the derivative, but every time you take the derivative of a different variable, you have to multiply by, in this case, dx dt, and multiply by, in this case, dy dt. So the derivative of this, which is x squared plus y squared to the 1/2 power, is 1/2 x squared plus y squared to the -1/2 times the derivative of what's inside. The derivative of x squared is 2x dx dt. And the derivative of y squared is 2y dy dt. Okay, so we can factor a 2 out and cancel it with this 1/2. So on the top we've got 2 times x dx dt plus y dy dt over 2 times the square root of x squared plus y squared. 2's cancel. Notice how I did that? I canceled something that was being multiplied. I did not cancel something that was being added or subtracted. I think sometimes when I cancel that stuff, I change the way your brain works in a bad way. So I'm going to factor the 2 out and cancel the 2 that's over there. Okay, any questions about that? Yes.
Why does it change to dy?
Because we took the derivative in terms of time. So the assumption is x and y are both negative. What is this? Is this a circle? Is this a radius of a circle? Is it a triangle? x is changing, x is changing, y is changing, right? And the hypotenuse is the distance between x and y. So if the rate of change of x is like -1 or 2 or something like that, 2 units per second, then this is always moving like that. And if the change in y is positive 2 units per second, this is always changing like that, 1 or 2. And then the hypotenuse, oh Jesus. I don't mind that. And the hypotenuse is always changing as well. So, so if the x value is changing from negative, then this hypotenuse has to reach a little bit further as it's moving to the left. This is moving up. You can see the hypotenuse is changing in a positive way. It's getting longer and longer. So, assume that the radius of the sphere is a differentiable function of time. So we have a sphere, right, and the radius is changing as time moves. So it's like blowing up a bubble or something like that. Right? Let B be the volume of the sphere. Find an equation that relates dV dt and dr dt. So the question is asking you to find an equation that relates V and R, and then take the derivative in terms of time, and that'll relate dV dt and dr dt. So what's the equation that relates the V, volume of the sphere, and R, the radius of the sphere?
It's the formula for what the volume of the sphere.
Volume of the sphere, yeah, that'll do it. The volume of the sphere, I don't know if you knew this, but the derivative of the volume of the sphere is the surface area of the sphere. Anybody know the formula for the volume of the sphere? Surface area, the area of the sphere is 4 pi r squared. Interesting enough. So the area of the great circle, if you slice a sphere exactly in half, you get a circle, right? And the area of that circle is pi r squared. The surface area of the sphere is 4 times that area of the circle. Isn't that crazy? So if you add 1 to the power and divide by the new power, what's the volume of the sphere?
4/3 pi r cubed.
That's the volume of the sphere. Okay? So let's relate dV dt and dr dt. What's a variable here? What's a variable here? R. Pi is not a variable, just some number. So we have a constant, 4 pi over 3 times the function r cubed. Okay, so dV dt is what? Remember, we're relating dV dt and dr dt. Take the derivative of that.
4
Say it.
4 pi r squared, right?
Times we're relating dV dt and dr dt.
dV dt r cubed 3r squared.
4 pi r squared dr dt. We took the derivative of this variable r, or this function r cubed, the variable r, and we have to multiply by the derivative of what's inside. Using the chain rule, multiply by dr dt, the rate of change of the radius as time goes. So what they'll do is they'll give you, at the moment that the radius is 2, the rate of change is, of the radius is 3 inches per second, positive 3 inches per second. So you plug 3 in there, you plug 2 in there, and then you get the rate of change in volume. Just by putting that stuff in. Okay, any questions? Assume the radius and height of a cone are differentiable functions of time. Okay, so we've got, so we've got a cone, might be a pile of sand or something like that, right? The height is changing, and maybe the radius is changing. The radius and height, R and H, are differentiable functions of time. And V is the volume of the cone. Find the equation that relates dV dt, dr dt, and dH dt. Where are we going to start here? What equation do we need here?
What the area of the cone.
The volume
Yeah.
is it V of a cone. Anybody know what it is?
1/3.
It's what?
1/3. Is it 1/3? Or is that?
It is 1/3 pi r. Yeah, pyramid and cones are 1/3 of the
Yeah.
full version. So what's the area of a cylinder, you remember? Area of the base times the height. Pi r squared h. So it's 1/3 pi r squared h. Here's the volume. Now, what changes? Does the volume change?
No.
Yeah, because it's got a dV dt,
Oh.
right? Because it has a rate of change, that means it's changing. What about r? Is that changing? Yeah, because it has a, it doesn't say the radius is constant, right? What about the height? Is that changing? Yes, so we have a product of two functions. You have to use a product rule. So dV dt, the first times the derivative of the second. What's the derivative of h in terms of time?
Is it just the HTT?
It's just dH dt. Plus the second h, times the derivative of the first. That's the derivative of pi over 3 r squared.
Two pi.
2 pi over 3 r
DR.
dr dt. Two-thirds times r times dr dt times h. There it is. That's the equation that relates all this. Any questions? 6 minutes, no problem.
Hey.
8 minutes. Matters practically 10. Hot air balloon rising straight up from a level field is tracked by a rangefinder 500 feet from the liftoff point. Here's the guy. Name is rangefinder. He's 500 feet from the liftoff point. From a hot air balloon rising. The moment the rangefinder's elevation angle is 4 pi, besides 500. Angles pi over 4. The angle is increasing at a rate. The angle is increasing at a rate of 0.14 radians per minute. What is that in calculus? The rate of change of the angle in terms of time. Like the rate of change of the radius in terms of time is the RDT. The rate of change of the height in terms of time is the HDT. The rate of change of the volume in terms of time is dVdt. What's the rate of change of the angle? Kind of. In calculus, we don't use A for angle measures. Theta, theta dt. This is d theta dt. How fast is the balloon rising at that moment? What are we looking for? The rate of change of the
Height.
height. What are you going to use for height?
dx
D what?
No, I'm sorry.
D, what did you say?
H.
That's a good choice if it's a cone. Like, I mean, when I look at this, actually I probably made this backwards. I would have put 500 here so it's in the positive direction. And I would have made this X and this Y and then this angle. I would call it Y. But H is a good choice. It's not so bad. But we're looking for dy dt. And we need to relate this angle, this distance that we have, and this side. Can you think of anything on a triangle that relates an adjacent side or the opposite side?
Cosine.
Cosine uses hypotenuse with sine, right? So tangent ways. So we've got tangent of theta is opposite y over adjacent 500. And we're going to take the derivative in terms of time of that equation, and we'll be able to relate these rates of change, the change of the angle and the change of the altitude. Okay, so what's the derivative of tangent of theta in terms of time? Secant squared theta d theta dt equals this is the constant 1 over 500 times y, right? 1 over 500 times y. What's the derivative of y in terms of time? Yeah, so we could say dy dt over 500, or we could say 1 over 500 times dy dt. What are we looking for?
What would this be? Or the rate of change?
We're looking at the rate of change of height, right? We're looking for dy dt. So we multiply the side by 500, we get dy dt alone. So dy dt is secant squared theta. Did they give us a theta value? Yeah, at the moment the angle finder's elevation angle is pi over 4. So what's the secant of pi over 4? Remember, at pi over 4, the coordinates of that point are square root of 2 over 2, square root of 2 over 2, which is 1 over square root of 2, right? Reciprocal of that for cosine is square root of 2. So this is square root of 2 squared. Do we know what the theta dt is? Do we know what the theta dt is? The angle is increasing at a rate of 0.14 radians. It's 0.14 That's divided. 1,000 times 14. I mean, 0.14. And square root of 2 squared is 2. 2 times 500 is 1,000. 1, 2, 3. Do you get 140? 140 feet per minute. 140 feet per minute. So we'll have questions like this on the quiz next week, Tuesday, just before Thanksgiving, and then just before Christmas. We only have 2 assessments left. So we won't have a test 2 on related grades. That's the good news. Unless I start next semester with quiz, test 1 and test 2, and then we start next semester with one of these. Yes,
So are we having still a test this Friday, or we're just doing it on Tuesday next week?
just choosing next week. Yeah, because of tomorrow. I'm excited about this field trip. It's gonna be fun.
Let's hope.
Oh, we can do another one. Oh yeah, we can still do it tomorrow. It'll be fun.